All right, Spartans, again, thank you for letting me do this video in lieu of being with you at class today. I am attending a doctor's appointment. So, thank you for paying attention and being good in class for Mr. Fay while he answers any questions that you might have. All right, we're going to start with this opening exercise. I'm going to walk you through it because I don't think we're to the point where we're able to prove formulas yet. So let's start with this. Let's assume the letters X, A, and B are all positive real numbers. And let's set another couple of constraints. Let's say that A can't equal 1, B can't equal 1, and I want one more thing that they don't put here. I want to say A can't equal B. All right? So these are our constraints. These are things that I don't want to have happen. I don't want A to equal B. I don't want either one of them to equal 1. And I want them to all be positive real numbers. Okay, then it asks me, what is the log base B of X in terms of log base A of X? What are they asking here? Well, they want to know what log base B of X, don't write this down, just listen. They want to know what log base B of X is. So they want it to be equal to a bunch of stuff that has log base A of X somewhere in it. Okay? So that's what we're looking to do. And the question is, how do we go about doing it? I'm going to show you real quick, and then just follow along with me and write stuff down. Okay? If I go too fast, just ask Mr. Fay nicely to pause the video so that you can catch up. All right? So first thing I want to do is I want to consider log base B of X. And I want to substitute a quality in to log base B of X. Instead of X, I want to substitute something else in here. In order to figure out what, I am going to use the log rule. Okay? B to what power equals X. So if I want X to equal something with B as its base, I'm just going to assign another variable because I don't know what X is, right? And I don't know what B is, so I need another variable. And I'm going to choose capital L for my variable. Okay? So now I'm setting X equal to B to the L power. And you might be asking yourself, why would you do that? And I will show you in a second here. So now X equals B to the L. Now here is what we want to know. When I say what is log base B of X, so if X equals B to the L, then log base B of X, again, B to what power equals X? Well, I know that X equals B to the L power, right? Oh, snap. I don't like that. There we go. All right, let me erase this the right way. I know X equals B to the L power. So B to what power equals B to the L power? That is obviously L. Okay? So log base B to X equals L. Now, think about this. If I have log base A of X, isn't that the same thing as saying log base A of B to the L power? So simply what I have done is I've replaced X with B to the L power. I've used this property right here. Now, this equals log base A of X. Now, I'm going to use my power property. Remember, my power property says, well, if I got a exponent in here, I can bring it back out into the front as a coefficient. So that's what I'm going to do right now. I'm going to say log base A of B to the L power equals L times log base A of B. And that equals log base A of X. And now I am going to solve for L by dividing by log base A of B. And divide this side by log base A of B. On the left-hand side of my equation, the log base A of B's cancel out, and then I get, this is where I'm going to borrow some space from down here. I'm going to say L equals, and remember, L is the same thing as log base B of X, right? L equals log base A of X divided by log base A of B. Which then means now erase the L and replace it with this guy right here. So log base B of X. So now, why do I need to know that? Why do I need to know that formula? Well, I need to know that formula because if I ask you to find log base 3 of 17, do you have that? Can I figure this out easily just by looking at it? 3 to what power gets me 17? There is no round whole number that gets me, when I take 3 to that power, and get me 17. So what I have to do is I have to use my calculator. But your calculator doesn't do log base 3. It does log base 10, and it also does natural log. So then this equals log base 10 of 17 over log base 10 of 3. And I plug that stuff into my calculator, and let's do that right quick. Let's turn this on and do log of 17 divided by log of not 10, 3, and I get 2.5789 is the answer. So 2.5789. Now, to know if this is right, I should be able to take 3 to the 2.5789 power. So I'm going to do 3 to the, and I'm going to pick my answer button. That means 3 to the 2.5789 power, and hit enter, and lo and behold, I get 17. So 17 is 3 to the 2.5789 power. Okay? Now, let's do these. Let's approximate each of the following logarithms to 4 decimal places. Use the log key on your calculator rather than logarithm tables. I want you to pause the video and do these on your own. This is calculator practice right here. Letter A is calculator practice. So pause the video and do it. When you come back, I'll have it ready for you. Okay, now that you're back, let's do it together. Let's move this. Let's move. Come on. Let's move this over here. It won't let me move it over there. Okay, so I do log base 10 of 3 squared. So log, no, did it wrong. So log base 10 of 3 squared, nope, 3 squared, enter, and I get 0.9542 equals 0.9542. Now I want you to do log base 3 of 2. This one we really shouldn't need a calculator for because we can just apply the log rule. 3 to what power gets me 3 squared? Well, that should be fairly simple. That answer is 2. 3 squared gets me 3 squared. All right, now this one is the tricky one. This one we have to use the change of base formula. So now I'm doing log base 2 of 3. Well, remember, this equals log base 10 of 3 squared divided by log base 10 of 3. Right? Is that right? No, I'm sorry, not of 3. Not of 3. Log base 10 of, gosh darned it, log base 10 of 2. So now I get, well, I've already done log base 10 of 3 squared. That answer is right there, 0.9542. So 0.9542 divided by log base 10 of 2. I haven't done that one yet, so I need to do that one. Log base 10 of 2 equals 0.301. 3010. So this is 0.3010. And then I take 0.95242, 0.9542 divided by 0.3010. So 0.9542 divided by 0.3010. Enter, and I get 3.1701. 3.1701. 3.1701. So what that's telling me is 2 to the 3.1701 power should get me 3 squared. Let's try it. 2 to the answer power, oops, delete, enter, and I get something real close to 9, which is another way of writing 3 squared. So there you go. We've used the change of base formula. All right. Now that we've looked at how to do the change of base formula, I want to jump ahead to, I believe it's the 3rd page. Yeah, it's exercise 4 on page S.84. So you should have down in the corner here, you should be on S.84, and we're going to look at ln. Everybody look to your calculator, find the button. Am I recording? Yes, I'm recording. Everybody find the button that is ln. I put it on the left here. You'll see my ln button is right below. Oh, sorry. My ln button is right below. I'm sorry. My ln button is right below the log button. So if you find the log button, right under it is the ln button. Okay? We're going to use that. You're going to find out what that means. Okay? So we're going to do the natural log of 1. That's what ln means. So ln means the same as natural log. That's how we say it. Natural logarithm. And it is the same as log base e. So if you remember earlier, we talked about Euler's number. And Euler's number was approximately 2.718. Okay, it's an irrational number, meaning it never ends and it never repeats. But it is a special number, and you'll learn a little bit more about that in pre-calc next year. But we're talking log base e now. And the reason it's special, like I said, you'll learn about it a little bit in pre-calculus. You'll really learn about it in calculus. But let's do some calculator practice first. We're doing the numbers 1, 3, 10, 25, and 100. So we're doing those 5 numbers, and we're going to find out what those values are. Okay, so natural log of 1. I go to my calculator, and I hit the ln button. Again, that stands for natural log of 1. And I hit enter. And I get natural log of 0. Okay, So, or I'm sorry, not natural log of 0. I get the natural log of 1 equals 0. And if I do my log roll, remember, I am thinking there's an e there. E to what power equals 1? Well, any number to the 0 power equals 1. We know that as one of our rules for exponents. Okay? Similarly, we know that the log base 10 of 1 also equals 0. Okay? Those are what I would call trivial answers. Let's go a little bit more in depth. Let's do natural log of 3. 1.0986. 1.0986. Let's do natural log of 10. Natural log of 10. And I get 2.3026. 2.3026. You should be doing these on your calculator. Take a minute, pause the video, do D for natural log, do E for natural log, and then do the rest of the common logs, the log base 10s. Do those all on your calculator. Pause the video, do those, and then unpause it, and we'll go over them together. Okay. Natural log of 25. So now you're back. We're going to do natural log of 25, and I get 3.2189. 3.2189. Natural log of 100. Oops, clear. Natural log of 100, and I get 4.605. 0.6052. Okay. Log of 3. Log 3. Enter. 0.4771. 0.4771. Log of 10. Well, 10 to what power gets me 10? 10 to the first power gets me 10, right? 10 to what power gets me 100? I'm looking at this one. Common log of 100. Do the log roll. 10 to what power gets me 100? This is 2. Okay? The only other one I need the calculator for is common log of 25. And that's 1.3979 equals 1.3979. Okay? Now, what happens to my logarithms? They start at 0, and then they go up. They go up fast at first, right? From 1 to 3, it goes up by 1. From 3 to 10, it more than doubles. But then, from 10 to 25, it goes up just over 1. From 25 to 100, it goes up just over 1. It's getting bigger, but more slowly. And the same thing for common log. It's doing the same thing. It gets big fast, not as fast as natural log, but it gets big fast, right? From 1 to 10, it goes up 1. But it has to go up to 100 to get to 2. Where would it go to get to 3? How much would I have to go to get to 3? Log of what equals 3? Log of 1,000 equals 3. Log of 10,000 equals 4. And we could go on and on. Okay? So, the conjecture is both go up quickly at first. Excuse me. Remember, natural log increases faster. But increase more slowly as I take the log of a larger number. Okay? take a moment, copy that down, and then let's move to... Now, the reason we went over that is because here's the beautiful thing. I can use the change of base formula. Like if I want to do log base 2 of 7, I don't have to use common log. I can use natural log. So this equals the natural log of 7 over the natural log of 2. Let's use that real quick and see what happens. So natural log of 7 divided by the natural log of 2. And I get 2.8073. 2.8073, which means 2 to the 2.8073 power should give me 7. Let's try that. 2 to the answer power, enter, and I get 7. Look at that. Winner, winner, chicken dinner. So I can use common log or I can use natural log. Remember, common log is base 10, natural log is base E. Now, we're going to write number 7. Again, we're going back to the product property. We're going to write this, we're going to condense this expression into a single logarithm. So let's do that. Natural log of 4. I'm going to leave that, I'm going to leave that alone for now because I'm going to focus on this guy right here. Natural log of 4 minus the natural log, and I'm doing the power property backwards, 1/3 to the 3rd power plus natural log of 2. So now I got natural log of 4 minus the natural log, and I'm going to do 1/3 to the 3rd power, which is 1/27, plus natural log of 2. And now I can do the product property. Whoa, no, I can, let's go. I'm going to bring this guy, remember, this is natural log of 4 plus -1 times the natural log. Let's get rid of this parenthesis right here. I don't need it. -1 times the natural log of 1/27 plus natural log of 2. Oh, and now I can do the power property again, bringing this up here. So this is natural log of 4 plus natural log of 1/27 to the -1 power plus natural log of 2. Now the beautiful thing is I'm going to start over here again. This is natural log of 4. 1/27 to the -1 power is natural log of 27. That is rules for exponent number 8, and then plus natural log of 2. And now I can do the product property. 4 times 27 times 2 is natural log of 4 times 27, that's 80, plus 28, that's 108. 108 times 2 is 216, and there's my answer. Written as a single logarithm. Same thing goes for letter B. Letter B is natural log of 5 plus, and now I'm going to do the power property, plus the natural log of 32 to the 3/5 power, and that's minus natural log of 4. Now, 32 to the 3/5 power. Think about this. 32 to the 3/5 power. It's the 5th root of 32 cubed. So, 5th root of 32 is 2, right? 2 times 2 is 4. Times 2 again, so 2 to the 3rd power is 8. 2 to the 4th power is 16. 2 to the 5th power is 32. So the 5th root of 32 is 2. And then I cube that. So this is natural log of 5 plus natural log of 8 minus the natural log of 4. And now I apply the product and quotient property. It's going to be natural log of 5 times 8 over 4, which equals, I can reduce that fraction to 2, and this is natural log of 10. Okay? So, there you have it. There you have it. Now, what's the point of that? Well, we can do the same thing with values of x. We don't need to do anything differently just because there's x's in there. Now, let's look at this more closely. Let's rewrite this square root of 5x cubed as an exponent, right? So this is going to be the natural log of 5x cubed all to the 1/2 power over e squared. Now, quotient rule equals natural log of 5x cubed to the 1/2 power minus natural log of e squared. Now this guy right here, that is asking e to what power gets me e squared. So we should be able to figure that out without even thinking about it. That should be 2. This guy is 2. Okay? If you don't believe me, let's do natural log of e squared. And finish my parentheses and hit enter. And lo and behold, I get 2. Look at that. All right, so I get equals natural log. Ooh, before I do that, I'm going to bring this 1/2 out here, power property, 1/2 times the natural log of 5x cubed minus 2. And this equals 1/2 times natural log of 5 plus, I'm going to put brackets around this, let me fix that. Oh, let's do it this way. So let's rewrite this. This is 1/2 times the natural log of 5 plus 3 times the natural log of x. Oops. I want that to be a square bracket. And then minus 2. And then finally, last step is distribute the 1/2. Boom, boom. And I get 1/2 natural log of 5 plus 3/2 natural log of x minus 2. Okay? So I can do that just the same as I could with numbers, except I'm using x's. Now, I can evaluate the natural log of 5, and I can times that by 1/2. So I'm going to do that. So 0.5, same thing as 1/2, times natural log of 5. And I get 0.8047189,562. I'm going to minus the 2, and I get negative 1.1953. So this equals negative 1.1953 plus 3/2 natural log of x. Okay? And that is my final answer. Okay. Now, for your assignment, you're going to have practice set. Number 1, all 3 problems. Number 2, you're going to have letters A and B. Number 10, A and B. And number 14, A and B. And this will be due on Wednesday. Thank you for your patience today. Have a wonderful day.